There are 118 elements, but have you ever wondered how these were made? You might think that all these always existed. However, just after the Big Bang, there was only hydrogen and helium. At first, there was only protons and neutrons. These combined to form hydrogen and helium. Further recombination proved impossible though, because when a hydrogen and helium atom would fuse to lithium, it would fall apart again. And similarly, when two helium atoms would fuse into beryllium, it would also break apart into helium atoms. The creation of heavier atoms was therefore blocked by this. So, how would other elements form? Well, a second method is nuclear fusion inside stars. Stars fuse hydrogen to form helium, and just like during the Big Bang, inside stars, two helium can be fused to form beryllium, and again, this will fall apart to form helium. But stars live longer, the concentration of helium gets higher and higher, and when the amount of helium gets very high, it's possible for three helium atoms together to form carbon. First, two heliums fuse to beryllium, and then third helium added before it falls apart again. Once you pass this beryllium blockade, fusion can create a much larger range of elements. When carbon is being formed, a lot of helium is around, and this can be added to carbon to form oxygen. Another helium can be added to form neon, and then magnesium, and then silicon, and silver, and argon, calcium, titanium, chromium, and finally iron and nickel. In each of these steps, more energy is released. This is called alpha process. But fusing elements heavier than nickel is much slower, and this does not happen inside stars. Also, while there is a lot of helium around, there is still hydrogen in the star. Hydrogen can also be fused with all these atoms to increase their atomic number by 1. Carbon can form nitrogen, oxygen can form fluorine, and so forth. All elements from carbon to nickel are made inside stars. Stars don't only produce new elements during their life, but also during their death. The third method to produce heavier elements is a supernova at the end of a star's life. During a supernova, the core of a star collapses. All the atoms are pressed together and a lot of energy is released. These are the ideal conditions to force nuclear fusion of elements that are heavier and require energy to be fused together. This creates elements well beyond nickel. Most of the created elements have atomic numbers up to around 60, but some very heavy elements like lead are also made, and some very light ones like lithium. The fourth method that made the elements is the neutron star merger. A neutron star is a small but extremely dense leftover after a large star died, if that star wasn't large enough to leave a black hole behind. We're talking about stars with masses between 10 to 25 times that of our Sun. If two of these neutron stars collide, a supernova-like explosion happens. In this explosion, heavy elements are made, just like in supernova, but here the average element created is even heavier. But all the elements created by a supernova are also created during this neutron star merger, and vice versa. Now, notice that there is a small hole in the table for atomic numbers 4 and 5. These are beryllium and boron, which get skipped over when nuclear fusion happens in stars. They're made using a fifth method, by cosmic rays hitting atoms. When cosmic rays hit a nitrogen atom, it falls apart into helium and unstable beryllium, which transforms into boron. These rays can also fragment others, like carbon and oxygen, to form lighter elements. In theory, these 5 methods could produce all elements. In practice, some of the elements just don't last that long and get transformed to other elements by radioactive decay. So, some elements on Earth get produced by a sixth method. They're the products of radioactive decay. There are 3 major radioactive decays. The first is alpha decay, where a helium atom or alpha particle is expelled. This lowers the atomic number by 2. The second is beta decay, where a neutron is transformed into a proton. This increases the atomic number by 1. And finally, spontaneous fission, where an atom is split into two fragments. On Earth, there are two very heavy atoms that are radioactive but nevertheless decay very slowly. These are uranium and thorium. These two can make even heavier atoms by beta decay. They also form what's known as decay chains, where uranium decays into thorium, then into radium, then into radon, then to polonium to finally form lead. Spontaneous fission of uranium can also make promethium and technetium, two somewhat lighter elements that happen to be too unlucky to be stable. For elements heavier than plutonium, there's a seventh and final method. They're made in a lab by humans. Elements up to fermium have been found in nuclear test sites as well. But for anything heavier, we just bombard heavy atoms with very fast lighter atoms to make even heavier atoms. For example, in the 60s, plutonium was bombarded with neon to make element number 104, rutherfordium, which then promptly decayed within a second, as these super heavy elements are very unstable.